Hello. Here we are again with the third episode of the Piping Fundamentals series. In this video, we will talk about an important subject for any engineer, not only piping disciplines. This topic will judge the quality of your product, whether it is a design, fabrication or even an idea. Its compliance with the state-of-the-art technology is of a prime importance that will determine its value in the market. Codes and standards will be our guest for today. Let's imagine a product that is not according to standard. This product will be of lower quality. If the small components fabricated in another place, most probably they not connect to each other and we will have serious problems in the assembly. Non-standardized products may be dangerous. Manufacturers would be obliged to invent their own individual solutions to the simplest need. We can find the standards in all aspects in our lives, in communications, media, healthcare, food, transport, construction, energy. So, what standards offer to our products? We will have safe product that was built according to verified quality. The production process will have a less impact to the environment, as it uses proven technology and materials. Governmental bodies usually adopt standards and put legislations to incent the application of them, to protect both users and business interests. The Unified Product Specification opens up market access and provides economies of large-scale production. Where we can find standard success stories. Mobile communication technologies. W-lane standards, Wi-Fi. Stud bolts and its unified thread system. At this point we have to put a definition to standards. A standard is a set of technical definitions and guidelines that were developed by experts, and function as reproducible instructions for designers, manufacturers, operators, or users of equipment. A standard does not necessarily need to be developed by international bodies such as ISO or ASME. Any organization can set their own standards for internal or external use. What is code? Code is a standard which has been adopted by governmental bodies and is enforced by law. Such as in some countries you have to build any pressure vessel above 6 inches in size according to code. Or when it has been incorporated into a business contract, therefore the contractor is obliged to this code during execution. What are specifications? They are technical requirements that are detailed and precisely described for any given product or process, and are heavily used during purchasing for controlling the quality of the final product. Recommended practice is a technical guidance and preferred procedures regarding a given topic to improve the process quality. Recommended practice is not obligatory unlike the codes and standards. And these are some examples of codes that are dealing with the design phase and material specification and testing. American Society of Mechanical Engineers, ASME. American Petroleum Institute, API. Det Norsk Veritas, the Norwegian Verification Bureau, DNV. American Society of Non-Destructive Testing, ASNT. Before we go farther through codes and standards the most used by piping engineers, we have to know how to use it. The first step is to shortlist these codes that you will use throughout your workflow, of course with advice of a skilled colleague. We can offer some help if you contact us on our pages at Facebook, LinkedIn or this channel on YouTube. The second issue, shall we memorize all these standards? The answer is surely no, as most of these publications are being updated and revised regularly. For example, Every 2 years the American Society of Mechanical Engineers issues an update to the Boiler and Pressure Vessel Code. What you have to do is to review the scope and contents of these codes, which is typically 1 page, and it is not subjected to changes during code update. Learn how to navigate through the code and to find out quickly the info you are searching for and where it is located, in which chapter or article. The first code we shall review is the American Society of Mechanical Engineers (ASME) Boiler Code Committee, which was formed in 1911. This committee put in the formwork after several serious explosions in the States during 1905, 1906. The first publication of the ASME Code was issued in 1914, whose name was Rules for the Construction of Stationary Boilers and the Allowable Working Pressures. The Boiler and Pressure Vessel Code has grown over the decades to include 13 sections that regulates the design and construction of boilers, pressure vessel and its components. These sections starting with Section 1, Rules for Construction of Power Boilers. Section 2, Materials with its 4 parts. Section 5, Non-Destructive Examinations. Section 8, Rules for Construction of Pressure Vessels, 3 divisions. Section 9, Welding and Brazing Qualifications, and ending with Section 13, Rules for Overpressure Protection along with code cases. Let's focus on Section 2, Part D, Material Properties. It provides tables of material properties including physical properties, external pressure charts and stress values that act as reference for other code sections. And this is the Table 1A that provides allowable stresses for ferrous materials. As you can see, it lists material specification number and grade, tensile strength, yield strength and other material properties that are used in various sections of Boiler and Pressure Vessel Code. In order to keep the code up to date of current developments in piping design, welding and new material specifications, and the increasing severity of service conditions, ASME developed B31 Code for Pressure Piping since 1935. The Code for Pressure Piping, B31, covers several industries and consists of Power Piping, B31.1, Process Piping, B31.3, Pipeline Transportation Systems for Liquids and Slurries, B31.4, Refrigeration Piping and Heat Transfer Components, B31.5, Gas Transmission and Distribution Piping Systems, B31.8, Building Services Piping, B31.9, Hydrogen Piping and Pipelines, B31.12. Let's review B31.3 Process Piping as an example. As agreed, the first approach is to read the scope of the code. It is rules for the process piping typically found in petroleum refineries, chemical, pharmaceutical, textile, paper, semiconductor, and cryogenic plants, and related processing plants and terminals. The following task is to analyze the content and coverage. This code prescribes requirements for materials and components, design, fabrication, assembly, erection, examination, inspection, and testing of piping. At this moment a question was popped up, and I will wait for the answers in the comments section below. Is piping beyond the outlet of the customer's meter set assembly included in the scope of B31.3? I can give you a hint for the answer. Kindly review the previous video definitions and terminologies. It shall take hours and hours to review only the shortlisted codes for the piping engineer. But as an advice, I will recommend the below list to review as we did previously. Read the scope, content and coverage and exclusion articles and give me your feedback and let's discuss about